This is AP Precalculus Notes for Topic 2.7, Composition of Functions. Let's start with some review to make sure that we're all on the same page. Consider the function f of x is equal to 2x minus 3, and we're going to evaluate the following. When you see this word evaluate, that just means plug in and simplify. So if I have f of 5, this means the x has been replaced with a 5, which means this x has also been replaced with a 5. So we are going to rewrite this as 2 not times x, but times 5. And then we're going to subtract 3. 2 times 5 is 10. 10 minus 3 is 7. And for these problems, more than other problems in the past, it's really important to box your work because you're going to have math everywhere. Maybe your answer is going to be there. Maybe your answer is going to be there. Please box your work. Now, instead of plugging in a number, I'm going to be plugging in a variable. Again, x used to be here because it used to be here, which means this c is being plugged in for this x. And I can say that this is 2 times c minus 3. 2 times c, you can't go any farther. You can just call that 2c minus 3, and we are done. When I'm plugging in 4a, again, you're going to, the main practice here is you're going to rewrite this exact expression, but in the place where you have an x, leave that an empty slot. That will help you in the future. So this is going to say 2, and there's my x, and I say minus 3. Notice how I'm setting it up. This x is just an empty container ready to plug in whatever I want. In this case, I'm plugging in a 4a into my empty container. So I can say 4a is being plugged in, and then I need to multiply 2 times 4a to get a 8a minus 3, and I can't go any farther than that because these are not like terms. That is a variable. That's a constant. All right, lastly, I have to plug in a 5x minus 1. Again, practice using that container method where you say this is going to be 2, there's my x, and then minus 3. I'm just rewriting my expression that I have here. And now that I'm going to plug in my x again is 5x minus 1. This is being plugged in for x. So I say 5x minus 1. And be careful here. You'll need to distribute the 2 into both of these two terms. Let me go ahead and draw an arrow saying I'm going to distribute here. And therefore, I'm going to have a 10x minus 2 minus 3. And then I combine my like terms. A minus 2 and a minus 3 is a minus 5. This is going to turn into a 10x minus 5. Again, box all of your final answers. All right, so a composite function is just a way of saying you plug a function into another function, or you plug an x into a function. You're just plugging it into each other. So let's see an example. So if I have a new equation, 3x plus 1, is that the same equation as before? No, it's a different one. Let's say g of 2 is equal to c, and I'm trying to find g of c. Well, there's a lot of information here. The first thing that I'm seeing is I can find g of 2. I have a g of x. If I plug a 2 into this x, then I'll find g of 2. Let's try playing with that first. So I say this is going to be g of 2. That means I'm going to kind of ignore everything here for a sec. 2 is being plugged in for this x, so I'm going to rewrite this as 3 times that plugged in 2 plus 1. And that's going to be 6 plus 1, which is therefore 7. All right, what do we know? G of 2 is now equal to a 7, which means this g of 2, I can kind of cross that one off and say that's 7, which means 7 is c. And now I can find what is g of c. G of c is, again, if 7 is c, this c is also 7. So I can say that c is 7, and I'm trying to find what is g of 7. G of 7 is equal to, and again, g of 7 means I'm plugging 7 in for my x. I'm going to rewrite this expression. This is going to be 3 times my container of x plus 1. What goes in that container? A 7 goes in here. And then I can multiply straight through. 3 times 7 is 21. And 21 plus 1 is 22. And there's my final answer that I'm looking for. Find g of c. Well, g of c is 22. All right. So, unfortunately, there are 2 ways that you can write composite functions. There's the first, and I don't know, I don't want to say bad, but it's my least favorite way. You can say f of g of x and write it like that. And you can also say f of g of x. And you can, these are exactly the same way. They're both pronounced the same way. They both mean the same way. This is a tiny little circle. It's not an O. It's not a 0. It's kind of like a dot that has some space in the center. I always read this as fog X when I was in high school, but it's f of g of X. So I will read these expressions as f of g of X for all of these cases. And we have the same expression down here, f of g of X. So when working with composite functions, we start on the inside first. You start with the inside g of X in this case. So we say inside, which feels wrong to a lot of students, right? Because normally we're taught to read from left to right, which means you start with f. Well, now we're telling you to do it backwards. Start on the right, start on the inside, and then once I have that, then you go to the left. So just be careful. It is kind of like following PEMDAS, right? Please excuse my dear Aunt Sally, where you start with parentheses. The most inside of the parentheses is that g of X. That's the reason that we start on the inside. So if that is my function, if my function is f of g of X, we're going to evaluate g of X first. So I'll write that down. Evaluate g of X first, and then use the answer from g of X and plug it into the next function. So the next function now is f. So plug that into f of X. So let's try another one. Example. So I have two functions now, and I need to evaluate the following expressions. So first, I have f of g of 3. Remember, we're evaluating the inside first, g of 3. So I'm going to just rewrite g of 3 now, g of 3. And g of 3, I'm going to rewrite this expression in the place where I have an x. I'm going to leave an empty spot, and then I'll plug some stuff in. So this is going to be 2 times that empty container of x plus 1. The thing that I'm plugging in is a 3. Again, this 3 and this 3 are the same 3. And then I can simplify, and I can say that is equal to 6 plus 1, and 6 plus 1 is 7. So what have I determined here? G of 3 is 7, which means this G of 3 is 7. What I really have here is f of 7. So I can say f of 7 now. I'm going to evaluate the outermost layer, and I'm going to rewrite this f statement down here using that empty container method. I'm going to say this is going to be 3 times my empty container of x minus 5. The thing that I'm plugging in is a 7 in this case. Again, this 7 and this 7 are the same 7. And I can just simplify here. So 3 times 7 is 21, and 21 minus 5 is 16. Again, box your final answer. Let's try another. So in this case, we're evaluating the inside. And at this point, usually you should try to do these problems on your own. If you're watching this YouTube video, please pause the video now. Do these and then play me at like ×2 speed to make sure you got it right, or you can just skip ahead using L on your keyboard. So I'm going to do f of 3 first. It's the most inside part of the function. F of 3 is 3 times my empty container of x minus 5. The number that I'm plugging in this case, is a 3. So this is going to turn into a 9 minus 5, and 9 minus 5 is 4, which means this now says g of 4. So I'm going to write down a g of 4. And g is invoking this equation. So I'm going to say 2x plus 1, and the x is that open container, which I'm going to put a 4 in. And this is going to be 8 plus 1, and 8 plus 1 is 9. And there's my final answer. I'm getting 9. All right, what about C? You can plug the same function into itself, which is kind of fun. Again, I'm going to evaluate the inside first. I'm going to say f of 4. This is going to be equal to. So I'm going to rewrite my f function, 3x minus 5. So come down here and say 3x minus 5. 3x minus 5. The number that I'm plugging in this case is 4. And I can evaluate that. 3 times 4 is 12. And 12 minus 5 is 7. So now this says f of 7. Let's go ahead and rewrite that. This is f of 7. And that's going to be 3 times my empty container minus 5. My container now holds a 7. And I can say that this is equal to 21 minus 5. And 21 minus 5 is 16. We got another 16. I think part A was 16 as well. Just a coincidence. Nothing super useful there. Let's try another one. So using the equations from example 2, still using this f, still using this g, let's try to do these. Notice the difference. Before we were plugging in whole numbers, and now we're plugging in an x. So this is really a fancy way, like g of x means plug x into x, which means you don't change it. So g of x is 2x plus 1. So really what's asking for is you have one thing and you're plugging it into another. So I'm really going to start with my outer container because I can't really do anything with the inner container. Just rewriting g of x is pointless to do. So I'm going to rewrite f of x, and I'm going to leave a giant space for the container for f. So I can see everything there. So I'm going to say f of g of x. I'm doing it all at one time. Maybe I don't need to rewrite that. I can just say this is going to be equal to, this is going to say 3x, lots of room, minus 5. I have rewritten 3x minus 5 right here. Guess what goes on the inside? This g of x goes on the inside, and this g of x is this g of x, which is 2x plus 1, which means that is the expression that I'm plugging in. This is going to be a 2x plus 1. And don't forget to distribute, so it's going to be 3 times the 2x, which is a 6x, 3 times the 1, which is a 3, and don't forget the original minus 5 that we had. Combining like terms, this 3 and this 5 are constant terms, so I can say this is a 6x minus 2 for my final answer, which I will then box. Let's try that same method again. Again, if you're watching the YouTube video, as you had to be watching the YouTube video, I'm uploading it after all, do this problem on your own. Please, please pause the video. I want you to practice on your own. If you just watch me do math, math is not a spectator sport. If I could watch basketball and be an amazing basketball player, then everyone would be amazing at basketball who watches basketball. To do math, it's the same way. Don't spectate, do the math. Do the basketball drills and you get better at basketball. Do these math drills, you'll get better at math. All right, I've gone on a tangent. You are already unpausing the video because you followed my instructions. So I'm going to rewrite g of x. This is 2x plus 1. I have just rewritten g. This g is 2x plus 1, which I've written down here. This f of x is being plugged into the inside. So this 3x minus 5 is being plugged in here. I'm going to say 3x minus 5, 3x minus 5. And now I have to worry about my distribution. So I say 2 times my 3x is 6x. 2 times my negative 5 is negative 10. And don't forget to add 1. And then from here, I'm going to combine my like terms. I'm noticing a negative 10 and 1 are my like terms. So I can say 6x minus 9. Final answer and box it. What's interesting about these examples is a person that hasn't done this before might expect g of f of x and f of g of x to be the same thing. Like, oh, you're just multiplying. 2 times 3 is the same thing as 3 times 2. Not with composite functions. These are going to be different values, assuming that they are not inverses of one another. We can talk about inverses at a later date, but in general, f of g of x and g of f of x, switching the order does matter. So be careful. You can't just willy-nilly switch the order. All right, moving on. I've got some more functions here. So I'm going to plug in, I'm finding h of 2 first. So h of 2, let's write you down. H of 2. All right, there's a bunch of functions. I have an h here, a k here, a p here, an m here. Obviously, I'm doing my h of 2 first. So I'm rewriting 2x minus 3, but leaving a spot for the x. So this is going to be 2x minus 3. In my container, it holds a 2 over here. So I'm going to say, there's my 2, and I can simplify that. I can say that's 2 times 2, which is 4. 4 minus 3 is 1. Okay, so that means this entire h of 2 is 1. I'm really doing k of 1 now. So I'm going to write that down. I'm going to say k of 1. Now I'm invoking a different equation. So there's my k function. I have 2 containers, 2 empty spots that I'll need to leave. So I'm going to write down x squared plus 4. There's my x. Plus 5, and into that vessel I put a 1 and a 1, and I just need to simplify here. So 1 squared is 1, plus 4 times 1 is 4, plus 5, and I see 1 plus 4 is 5, plus 5 again is 10, so my final answer here is 10, and I box my work. All right, now we have that other notation. I read this still h of m of negative 1. I'm doing m first. It's the one to the right first. You're reading kind of backwards in this case, and I know that's kind of confusing, but you do m of negative 1 first. So m of negative 1 is the first thing that I evaluate. Where is that m? All right, so m is this equation right here. So 3x plus 2. Let's write that down. 3x plus 2, and in my container I have a negative 1. So simplifying a little bit here, 3 times negative 1 is negative 3, and negative 3 plus 2 is a negative 1. So that means that all of that was a negative 1. Now I'm going to do h of my negative 1. So let's write that down. I say h of negative 1, which is kind of interesting, right? It was negative 1, and it's still negative 1. It happens sometimes that way. This is going to be equal to, okay, where's my h function? H function was that one from before, 2x minus 3. So I'm going to write that down over here. So 2x minus 3, 2x minus 3, and my x is a -1, and that's going to be a -2 minus 3, and these are the same signs, negative and negative, so you add them together, and this is going to be a -5. So final answer, and box it. For C, I am first evaluating P, and I'm putting P of X, which you can't really do anything. There's P of X. I've rewritten it right there. I don't need to do anything. So now that I'm done with P of X, which is right here, I just need to put it into K. So let's make K our empty slot. So where's K? K is, okay, it has 2 empty slots. So I'm going to rewrite this expression. Give me a lot of room. Remember, this square root of 3x plus 1 has to go into this x, and it has to go into this x. And that's a big expression over here to add. So give myself some room. X squared plus 4x plus 5. So x squared plus 4x plus 5. So 2 empty containers, and into those empty containers goes a square root of 3x plus 1, the square root of 3x plus 1, the square root of 3x plus 1. You can have as many x's as you please in any equation. Luckily, we only have 2 this time. All right, what I'm seeing here is a square and a square root cancel each other out. They are inverse operations, and I'm left with a 3x plus 1. And there's nothing you can really do here. If this was a radical, then I could distribute the radical into another radical. This is a non-radical and a radical. They can't do anything. They're just kind of stuck. So I have to say plus 4 radical 3x plus 1 and plus 5. So I do have some like terms here. A plus 1 and a plus 5 are the only like terms. And I can say that this is a 3x plus 6 plus 4 square root of 3x plus 1. Can't go any farther than that. Go ahead and box that. And there's no D. I can go on to, okay, so this is the penultimate challenge. This is the last problem before you go on to your worksheet 2.7a. We have a mixture of types of functions. We have a graph, we've got a table, we've got a piecewise function, and we've got a word problem. None of those are nice to use. None of them are easy to use. And before I move too much farther, I'm seeing some problems in all of these that you need to analyze before you even jump into A. How do you do this graph? For example, I'm asking the question now, what if I told you, what is f of 2? F of 2, well, I plug in 2. This is asking the question, what is the height when you plug in 2? Is the height 1 or is the height 4? In this case, the height is 1 because that's where I have my filled in point, my closed point. So f of 2 is actually equal to 1 in this case. But let me ask a harder question. I'm going to go ahead and erase this in a second. This is just for instructional purposes only. What about something harder? What about f of 5.5, 5.5? What do you do here? Well, you clearly say, okay, Mr. Sindel, 5.5 is right there. And you go up to a height of, okay, no, you go down to a height of, there is no height, which means it's undefined. Undefined, which means you can't go any further. You can't plug undefined into another function. You just stop there and you say, I can't go any further. It's undefined. There's no answer. So be careful about the graph. We've talked about the graph. Let's move on to the table. The table is interesting too, because obviously if you say, okay, what is g of -1? Well, the answer is 3. G of 2, yeah, answer is 3. But what if I told you, what is g of 0? That's the question, right? G of 0. Well, where's the 0 to plug in? I don't have a 0. It's also undefined. You need to be careful. You only can plug in values that the table gives you. Otherwise, you don't know it. And this is the way of saying we don't know it in math. What about a piecewise function? A lot of students struggle, like, how do you even use this thing? So again, let's do an example problem. What if I told you, what is h of -1? If I told you h of -1, how do I even use this thing? Well, these right numbers tell you a guide of what to do. Hey, are you plugging in a number that's less than 1? If so, do that equation. Are you plugging in a number that is 1? If so, do that equation. Are you plugging in a number that's greater than 1? If so, do that equation. So it's an if-then statement that's backwards, which is kind of funny. I feel like these should always be switched, like if this, then this should, yeah, we read from left to right, but randomly in math, we sometimes read from right to left, whatever. So to actually practice h of -1, -1 is, as you've guessed, less than 1, which means I'm plugging this -1 into this x. Not this one, there is no x to plug in, and not that x either, this x right here, which means you would say, just for practice, This would be the absolute value of -7 plus 3 times that -1 that I'm plugging in into absolute value. And you say, okay, 3 times -1 is a, cross that out and say it's a -3, and then -7 plus the -3 is a -10. Taking the absolute value of that turns into a +10. The final answer would be a +10. That's how you use the piecewise formula. And then lastly, we have a word problem. And we've practiced this in the past, but how would you do this word problem? We need to turn it into an equation. We should just do that now. This is something that you are going to have to write down, so get your pencil ready. We know it's a quadratic function. If you don't know what that means, quadratic means I have x squared somehow. And I have a horizontal translation of 2 and a vertical translation of -3. So hopefully you remember how to do those, but in case you've forgotten, k of x now, because I'm still talking about k here, k of x is going to be equal to I should do this in pen, it's going to be equal to something to the power of 2. I know it's something to the power of 2 because that's the definition of a quadratic function. And usually there's an x in here. Sometimes I have stuff being multiplied by the x. That's called a dilation. Multiplication and division is always a dilation, but I'm noticing I only have a translation and a translation. Translation is a word that means add or subtract, and therefore I have no multiplication. So horizontal means it's going to be on the inside of the parentheses, and it's going to be the opposite of whatever this number is. So if this is a +2, that means I need a -2 on the inside of the parentheses. And if I have a vertical translation, vertical is always on the outside of our parentheses, and it's the normal direction, so you don't change the sign. It's still -3. So on the outside, I write a -3, and look, we have turned a word problem into a function that is actually usable. All right, we have all the groundwork laid to solve example 5's 6 questions. So let's go ahead and do part A. First, I need to do the inside. I need to do g of 3. So g of 3. So what am I invoking here? Am I doing the graph? Am I doing the table, the piecewise equation, or the word problem? G is talking about this g, and that is a table. So where's 3 up here? There is no 3. There's -4, -1, 2, 5, and 7. You might be saying, oh no, there's 3 right there. That is an output. This is the input. Where's an input of 3? There is not an input of 3. So the answer here is immediately undefined. And because it's undefined, I can't even plug undefined into f because you just stop there. The answer is undefined, box it, and move on. What about part B? So first I'm going to be doing the rightmost function. I'm going to do f of 8. Let's find that. F of 8. F is talking about the graph up here, f, and 8 is talking, here, let me erase this little tick mark right there. 8 is talking about this x coordinate. So what is the height when you plug in 8? 8 has a height of -1, a y coordinate of -1. So you say, okay, that one is equal to -1. And now that I have that value, I'm going to plug it into h. What is h of that -1? So what is h talking about? H is talking about the piecewise function, and I just got lucky there. -1 is a number that I actually plugged in before. I do remember that's 10, but let's go ahead and show our work yet again. So I am going to re-explain this just in case you skip past this part of the video. -1 tells us I'm going to be going into this piece, not that piece, not that piece, because it's not equal to 1, it's not greater than 1, it's less than 1. So plug it into that x. I'm going to rewrite that equation down. That equation is the absolute value of -7 plus 3 times a -1 and absolute value. That's all there is to it. I just need to simplify now. So I can see here that this is going to turn into the absolute value of -7 minus 3, which is equal to the absolute value of -10, which is equal to just a +10. Remember, absolute value makes everything inside positive. So final answer, box it, move on to the next question. So the first thing I'm going to do is the rightmost function. This is going to be k of 0, k of 0. So how do I do k? Well, k is that function that we defined earlier. I just need to plug 0 into this x. So when I do that, I get, let's say this is going to be x minus 2 quantity squared minus 3, and into that spot we have a 0. So 0 minus 2 is a -2. I'm just going to show all of my work to make sure that we can follow. This is going to be a -2 quantity squared minus 3, and that's going to be a 4 minus 3, and 4 minus 3 is 1. So I know k of 0 is 1, and now I'm going to plug 1 into g. So what is g of 1 is the next question. G of 1. So g is using a table value, and where's 1? We don't have 1. It's undefined yet again. We got all the way to the end and it was undefined. It's kind of like finding the treasure only for it to be empty. This is undefined. undefined. Sad, but there it is. All right, let's move on to part D. F of 2. Evaluating the inside first. F of 2 is using the graph. So if I come up here, f of 2 is right here. Oh, it's one of the questions I talked about as well. So f of 2 has a height of 1 because I have a closed point here. This open point means that if I shot up like a firework, it would not hit that point. It would hit this point and then explode. So the height here is 1. So f of 2 from the graph is equal to 1. And now this is really asking what is f of 1. So let's go ahead and write that down. F of 1 is equal to, coming back up to the graph, when I plug in a 1, I have a height of, explosion right there, height of 4. So I come up here, or down here, and I say, that's a 4. Final answer, and box it. With graphs, there's usually very little work shown. All right, what about E? First, I'm going to do H of 1. H of 1. So when I do h of 1, let's come up here. H of 1 is talking about this function. So which of these slots am I talking about? Well, 1 is talking about this middle piece because I'm equal to 1, and I don't even plug in anything. The answer is just -4 without having to plug in anything. I say, that's -4. And now I know I'm going to plug in -4 into G. So I'm going to say G of -4 is equal to, well, G is that table again, right? Yeah, so G of -1, G of -4 is the first time the table actually works. There's my -4. When I do G of -4, I output a pi. So the answer to this one is pi. You can box that. And look at this monstrosity, F. Oh, it's G of F of H of K, which means 3 is plugged into K. Then the answer will be plugged into H. That answer will be plugged into F. That answer is plugged into G. What's the probability this is undefined? I think it's quite high. Let's find K of 3 first. Again, you move from the right to the left with composite functions. So K of 3 is this function right here. I'm going to rewrite it, but in the spot where there's an X, I'm going to leave a blank space. Let's zoom out just a little bit so I can see the function. There we go. So this is going to be, in pen, please, Mr. Sindel. We have our function X minus 2 quantity squared minus 3, and the value that we're plugging in here is a 3. So this is going to be, I might have to conserve room because this is a long problem. This is going to be equal to, all right, well, mental math, 3 minus 2 is 1. So I guess I'm not doing mental math. I'm doing it out and showing my work. It's 1 squared minus 3. 1 squared is 1, so that's 1 minus 3, and 1 minus 3 is equal to a -2. Okay, next it's going to be plugged into H. So this is H of -2. So I'm going to come up here, H of -2. Oh, okay, so H of -2, I'm talking about H, and -2 is less than 1, so I'm going to be plugging into this value right now. So I'm going to rewrite the absolute value of -7 plus 3x, but in the place of an x, I'm going to leave a blank space. This is going to be equal to the absolute value of -7 plus, was it 3x? I'm trying to remember. Yeah, plus 3x and absolute value, plus 3, and there's my x value and absolute value. My value that I'm plugging in is a -2. So I don't know if I'm going to have enough room. I'm going to do it underneath. Hopefully I have enough. This is going to be absolute value of -7 minus 6. And -7 minus 6 is, didn't mean to double tap there. This is going to be equal to a -13 on the inside of the absolute value, which is going to evaluate to a positive 13. And then I'm going to plug that into the next one. So we've done K, we've done H. Now it's time for F. It looks like it's going to evaluate after all. So this is going to be F of 13. So F of 13, that's the graph one, right? Yeah. F of 13, it only goes up to 10. Does it have something over here? We can't assume that. So we have to say undefined here. I knew it was going to be undefined. Undefined. It was not on the graph, therefore we can't say anything else. Excellent. Well, that concludes notes for topic 2.7 for AP Precalculus. There's the back side of the notes. There's the front side of the notes. Thanks for watching.